Today we will see solid state, unit cell, how the atoms are arranged in a solid state. That is each cubic, let us see that smallest repeating unit in space lattice, repeated over and over again. The results in a crystal is given in the substance is called as a unit cell. That unit is taken, each unit, a small cubic is taken, how much the atoms are arranged, that only are going to see, that is called unit cell. There are two types of unit cell. One is primitive or simple unit cell. Second one is non-primitive or centered unit cell. In primitive or simple unit cell, that only at the corners the atoms or particles or ions are present is called simple unit cell or primitive unit cell. Next, a non-primitive unit cell, both in at the center as well as in some other places, the atoms or particles or ions can be occupied. It is called non-primitive or centered unit cell. This non-primitive unit cell has three types. One is face-centered, body-centered, and end-centered unit cell. First, face-centered unit cell. Particles or atoms present at the corners as well as at the center of the faces. It is called face center, and body center. Atoms or particles or ions present at all the corners as well as at the center of the body of the unit. And end center, particles or atoms or ions present at the corners as well as at the center of the two opposite faces is called as a end centered unit cell. So face centered, body centered, and a end-centered or three non-primitive unit cell. So in this, now all the three non-primitive unit cell, all the corners contains and the particular faces and the body as well as at the opposite faces. Let us see the diagram of unit cell, primitive or simple unit cell and non-primitive or centered unit cell. First, simple unit cell, each corners 1, 2, 3, 4, fifth corner, sixth corner, seventh corner, eighth corner. So there are 8 corners in the cube, and this is called corner of the unit cell contains atoms. All the corners, 8 corners. Non-primitive or centered unit cell, already I said face centered, body centered, and end centered unit cell. In all the three centered non-primitive unit cell, corners it has atoms. So here 4 and bottom 4, 8. Even here also all the corners it has 4 plus 4, 8 atoms. End centered also it has 4 on the top, 4 at the bottom, 8 corner atoms. And here in face centered, this one face and second face, third face, fourth face. 1 and 2 and then 3, fourth one, 4 faces, and this is the front side of the crystal of atom, and this atom is at the back side of the crystal. And here only one body, it is body centered. Here two opposite faces will have one atoms. This is two or opposite faces. So now we see the atoms at corners. Here are 4 atoms, top 4 atoms, bottom 4 atoms at corners. That is called simple cubic. It is sharing by 1 by 8. So into 8, that is 8, 8 cancelled equal to 1. In faces, this is face-centered cubic. This face, the 2 atoms are joined together. It is called a face diagonal. And this is a face center and this is face. Then this atom is one face, left side face, right side face one atom, top side one atom, and a bottom one atom. This red color atom, front side of the crystal, and this is the back side of the crystal. So imagine this is, we'll consider as a one room or one classroom. If you take, it carries 4 walls. That 4 walls are touched by roof and floor. So the roof and floor are 1 by 2 will consider, that is sharing by 6. So 1 by 2 into 6, the face is 3 for FCC, and body center is only 1. And its center, you just see this. This is corners. Blue color are atoms, are the 8 corners, 8 atoms. And here, just below this blue atom, that is called edge of this. And then this is edge center now. If the atom is here, this is the edge center atom. So what? Almost a top 1, 2, 3, 4. And then if you take this face, edge 1, 2, 3, 4, edge center. If you take this face, 1, 2, 3, 4. If you take this face, 1, 2, 3, 4. So 4 into 4, 4, 4, 8. And here 1, just to count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. There are 12. So into 4 faces. So what? 1 by 4 into 12 equal to 3. So in simple cubic, 1 in face centered cubic, 3 and body is 1 and edge center 3. So totally 8. So here a simple cubic you have taken. In this simple cubic, 8 corners are there. All the 8 corners, 1 by 8 into 8 equal to 1 atom is sharing. So in FCC, that is 1 by 8 into 8. I told you almost FCC, BCC and its center, everything will have the corner of the atom, that is 1. Here also 1 by 8 into 8, 1. 1 by 8 into 8, 1. So here I already told you to consider one classroom. It is touch one a roof and a floor. Totally 6 faces into 1 by 2 is a 3. So 1 plus 3, 4. Here 1 plus 1, body 1, 2. And here 1 plus 3, 4. So these are the number of atoms present per unit cell. In FCC, atom per unit cell is 4. In BCC, atom per unit cell is 2. In its center, atom per unit cell is 4. So here, this is one. Again and again, I have written the atoms here. One face, 2, 3, 4, 5, 6. Then here body only 1. Here edge green color. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So for I return that as numbers are Z. Z equal to number of atoms present per unit cell for simple cubic 1, for face centered cubic 4 and body centered cubic is 2. It is very much useful for your almost useful for problems. So